Hello viewers, welcome to video number 109 of the channel MALACHEMPHILIC, and this video number 109 is the 49th episode of Chemical Thermodynamics, and the topic of this episode is Criteria of Spontaneity Part 1. So let's start. Now we know that from first law of thermodynamics, what we can write? We can write del Q reversible. Here we are considering heat absorbed. Heat absorbed reversibly is equal to dE minus del W reversible. Okay. Then again from second law, we know that this del Q reversible is equal to TdS. All these things I have derived earlier. Okay. So here we can write for reversible process TdS is equal to dE minus del W reversible. Okay. Yeah. Now del Q, again we know that del Q irreversible is less than del Q reversible. Okay, already you know, because work done in the reversible process is maximum. Okay, so therefore this also I have explained earlier. So del Q irreversible will be less than del Q reversible, right? So now TdS means that is equal to del Q reversible. So TdS is greater than del Q irreversible. We can write TdS is greater than del Q irreversible. Again, del Q irreversible means what? Del Q irreversible, heat absorbed irreversibly, that is equal to dE minus del W irreversible. Okay. So what we can write? That TdS, which is greater than del Q irreversible, that will be greater than dE minus del W irreversible. Okay. So this is equation 1 and this is equation 2. So combining 1 and 2, how we can write? So combining 1 and 2 means combining 1 and 2 or reversible and irreversible. What we can write? This TdS greater than for irreversible and is equal to for reversible dE minus del W. Okay, this is combining both reversible and irreversible. Greater than for irreversible is equal to for reversible, right? So from here we can write TdS minus dE plus del W greater than is equal to 0. So same equation I have written, TdS minus dE plus del W greater than is equal to 0. Now this already I told you, this equality implies a reversible transformation or an equilibrium state. Reversible means it remains in equilibrium. And the inequality refers to an irreversible change, that means spontaneous process. Since all the irreversible changes are spontaneous, it means that the inequality gives the condition for a process to occur. So that inequality part, greater than part, it gives the condition for the spontaneous process or the process to occur. In the above equation, del W includes both mechanical and non-mechanical work. If the system involves only mechanical, that is pressure volume work, then the equation will become TdS minus dE plus del W means minus PdV greater than is equal to 0. Okay. So here greater than indicates the irreversible process or spontaneous process. Is equal to indicates the equilibrium. Right. Now one by one we'll just see. So this is the main equation. Okay. Now first we'll do spontaneity number 1. Spontaneity in terms of entropy. Okay, write down this common equation. TdS minus D minus PdV greater than is equal to 0. Now if we put the condition at constant energy, D is equal to 0. Okay, at constant volume, dV is equal to 0. Okay, so TdS D0 dV 0 under this condition greater than is equal to 0. So D is greater than is equal to 0. That means what we can say? For an isolated system is isolated. Okay. That means no energy transfer with the surroundings. For an isolated system, if the energy remains constant, that means at constant energy and volume, if entropy increases, that indicates the spontaneous process. Decreases means non-spontaneous. If there is no change of entropy means that is in equilibrium. System is in maximum entropy. Right? So, therefore, what we can conclude? For an isolated system under constant energy and volume, increase in entropy indicates irreversible or spontaneous process. Okay. So decrease in entropy indicates non-spontaneous process. Decrease in entropy indicates, under the same condition, indicates non-spontaneous process. And ds is equal to 0. That means no change in the entropy means system is in equilibrium. No change in entropy means the system is in equilibrium where entropy is maximum. So this is in terms of entropy, right? Now, next one is spontaneity in terms of energy. So, spontaneity in terms of energy. Okay. Same equation we have to take. What is that one? TdS minus dE minus PdV greater than is equal to 0. That is combined equation for reversible and irreversible process in terms of dE. So, we put the condition at constant entropy, that means ds is equal to 0 and constant volume, that means dV is equal to 0, then minus dE greater than is equal to 0, because this is 0, this is 0. So, dE will be less than is equal to 0. What does it mean? That means at constant entropy and volume, decrease in entropy, decrease part has come from this increase one, okay, minus, so it become decrease. Decrease in energy indicates irreversible or spontaneous process. Okay. So therefore D, increase in D greater than 0, non-spontaneous. And D is equal to 0, that indicates equilibrium. Equilibrium where energy is minimum. So this is the condition for with respect to energy. Now, third one. See, third one is spontaneity in terms of work function or Helmholtz free energy function. Work function or Helmholtz free energy function A. Okay. So let's see. So once again we write down the equation. TdS minus dE minus PdV greater than is equal to 0, which is the combined equation for reversible and irreversible. Now, work function. We know that A is equal to E minus Ts. Now differentiate. So, dA is equal to dE minus TdS minus SDT. So, from here, dE is equal to dA plus TdS plus SDT. Okay. Now, putting this expression of dE in this equation. Okay. So, we know TdS minus dE minus PdV greater than is equal to 0. Now I put the expression of dE. So TdS minus dE, that means minus dA minus TdS minus SDT and minus PdV greater than is equal to 0. Okay. Now we'll see TdS and TdS cancel. What is left over? Left over is minus dA minus SDT minus PdV greater than is equal to 0. So at constant temperature, dt is equal to 0. Okay. Then at constant volume, dV is equal to 0. So under this condition, at constant temperature and constant volume, what we can write? Minus dA greater than is equal to 0. Therefore, dA less than is equal to 0. Less than means irreversible. Okay. So, what is the conclusion? At constant temperature and volume, decrease in work function indicates irreversible or spontaneous process. So, therefore, at constant temperature and volume, decrease in work function or A, okay, indicates irreversible or spontaneous process. Okay. Therefore, when dA greater than 0, that means increase in work function greater than 0, that indicates non-spontaneous. And dA is equal to 0, that indicates equilibrium, where A is minimum. Okay. So this is the criteria for spontaneity in terms of work function or Helmholtz free energy function A. Now the fourth one, spontaneity in terms of Gibbs free energy function G. Okay. Once again write down the common equation, that is TdS minus dE minus PdV greater than is equal to 0. Combine equation for reversible and irreversible. Now we know that G is equal to H minus Ts. So G is equal to E plus PV minus Ts. If you differentiate, dG is equal to dE plus PdV plus VdP minus TdS minus SDT. Okay. From here, what will be dE? So dE will be is equal to dG minus PdV minus VdP plus TdS plus SDT. Okay. Now we put this expression of dE in equation number 1. Right. So what we'll get? Therefore, right here. Putting expression of dE in equation 1. Then what we are getting? TDS, this is minus D, so it will be minus DG plus PDV plus VDP minus TDS minus SDT, then minus PDV greater than is equal to 0. Okay, see, TDS cancel, PDV cancel. So what is left over? Minus DG plus VDP minus SDT greater than is equal to 0. Right? So at constant pressure dP is equal to 0, constant temperature dt is equal to 0, then minus dg greater than is equal to 0 or dg less than is equal to 0. This less than indicates the irreversible. So what is the conclusion? The conclusion is, this one I'll show you after this. The conclusion is, what is the conclusion? Conclusion is, at constant temperature and pressure, decrease in Gibbs free energy, Gibbs free energy indicates irreversible or spontaneous process. Spontaneous process. Okay? And when dg increases, that is greater than 0, that indicates non-spontaneous. Okay? And dg is equal to 0, that is equilibrium. That means that indicates equilibrium where G is minimum. Okay. Now the last one, spontaneity in terms of H, enthalpy, that is H. Okay, spontaneity in terms of enthalpy. Right? Achha. Once again the common equation will write TDS minus DE minus PDV greater than is equal to 0. So this is my equation 1. Okay. Now enthalpy H is equal to E plus PV. So dH will be is equal to dE plus PDV plus VDP. Right? So from here dE will be is equal to dH minus PDV minus VDP. Right? Now putting the expression of dE in equation 1. So putting the expression of dE in equation 1. What you will get? TdS minus d, that means minus dH plus PdV plus VdP minus PdV greater than is equal to 0. So look at here, PdV and PdV cancel. So what is left over? TdS minus dH plus VdP greater than is equal to 0. Okay. So what we got? That is TdS minus dH plus VdP greater than is equal to 0. Now at constant entropy ds is equal to 0, constant pressure dP is equal to 0. So minus dH greater than is equal to 0. Therefore dH less than is equal to 0. So what is the conclusion? At constant entropy and pressure, decrease in enthalpy of the system, everything of the system indicates irreversible or spontaneous process. Okay. So if increase in dH, okay, if dH greater than 0 or increase in enthalpy, that indicates non-spontaneous. And when it is equal to 0, that indicates equilibrium. Okay, equilibrium means where H is minimum, enthalpy is minimum. Okay, so these are the conditions for spontaneity in terms of entropy, work function, energy, Gibbs free energy and enthalpy with respect to system only, right? So we have come to the end of this video. Hope you have understood. Thank you.